Good day! For this video, we will show the capability of a data compression. I'm your speaker Jewel. Please enjoy and learn from the video. In the modern world, data compression is an unseen force with enormous power. There is a good chance that our modern computer age would not have taken off without the numerous innovation in the field of compression. All types of data can be compressed, including audio, video, text files, and image. Compression encodes an input data set using fewer bits than the original file would have been taken up on its own. But why compress data? On a computer, processing power and storage space are extremely valuable. To get the most out of both, we may need to reduce the file size of text, image, and audio data to transfer it faster and take up less storage space. Furthermore, large files takes much longer to download or uploading, resulting web pages, songs, and video taking longer to load and play when using the internet. These issues are addressed by compression. Before we explore more about data compression, here's a brief history of a data compression. With the introduction of information in the late 1940s, modern work on data compression began. In 1949, Claude Shannon and Robert Fano established a method for assigning code work based on a block probability. David Hoffman discovered an efficient way of doing this in 1951. Early implementation are often done in hardware, with precise code word choices intended to strike a balance between compression and error correction. The concept of dynamically modifying code words for Hoffman encoding based on real data encountered arose in the mid-1970s, and as online storage of text files became more prevalent in the late 1970s, software compression applications began to emerge, practically all which were based on adaptive Hoffman coding. Abraham Lempel and Jacob Zeef proposed the core concept of pointer-based encoding in 1977, following Terry Welch's discovery in the mid-1980s, and so-called LCW algorithm quickly became the method of choice for the most general-purpose compression system. What is data compression and how does it work? Data storage and transmission are frequently top priorities for business, governments, and other organizations. Data compression enables this organization to handle more data while using less space and money. The process of encoding, restructuring, and otherwise modifying data to reduce its file size is known as data compression. It entails re-encoding information with fewer bits than the original representation. Data compression is used all over the place. Compressed data is used by many different file types. A 3-minute song would be over 100 megabytes in size without data compression, while 10-minute video would be over 1 gigabyte in size. Data compression reduces large files to much smaller sizes. It accomplishes by removing unnecessary data while retaining the information in the file. In data compression, we have these two techniques that they call, and it is lossy compression and lossless compression. Let's know more about lossy compression. Lossy compression simply reduces the size by removing extraneous information and simplifying existing information. Lossy compression can provide substantially higher compression ratios at the expense of possible file quality loss. An MP3 audio file, for example, does not contain all of the audio information from the original recording. MP3 lossy compression, on the other hand, removes sounds that human cannot hear because the average human ear would not detect the difference. The outcome is a smaller file with a little user impact. JPEG is a popular lossy compression technology, which is why most images in the internet are JPEG images. Now we have lossless compression. It reduces file size without deleting any data. Instead, this format reduces total file size by reducing redundancies within data. The original file can be fully recreated using lossless compression. For example, because it keeps all of the original information, the most prevalent lossless compression format, zip, is frequently employed for program files on Windows. Unzipping the file provides an executable application that would otherwise be worthless using lossy compression. PNG for images, FLAC for audio, and ZIP are all common lossless formats. Lossless video formats are uncommon since the source files would take up enormous amount of space. Before we move on to the uses of data compression, here are some common methods for data compression. First, we have the Lempel-Ziv-Welch compression, run-length encoding, dictionary coding, and perceptual coding. And now, we are in the part where we learn the uses of data compression. According to Syed Khalid, an early example of data compression is Morse code, which was developed by Samuel Morse in the mid-19th century and employs the frequency of occurrence of single characters, a frequently used form of Braille code words, to produce compression. Audio compression. Implemented as audio codecs, audiophile compression is required to ensure that bandwidth and storage restrictions are not exceeded. Audio compression can be lossy or lossless, with MP3 being the most widely used lossy codec. FLAC is popular lossless audio encoding format. Image compression. It is a type of data compression applied to digital image to reduce their cost for storage or transmission. Image compression and audio compression are combined in video compression. Typically, separate codecs are used for each component of a video, which are then combined to form a single compression codec. Because uncompressed video requires a high data rate, most video files are encoded using lossy compression. MPEG is the most used type of lossy video compression. And now we move on to text compression. It can be compressed by removing extraneous character, embedding a repeat character to specify repeated characters, and substitute a smaller bit string for a frequently occurring bit string. Data compression can reduce the size of a text file by half or to a percentage that is still less than its original size. These are only few of many possible layouts that can be utilized to achieve compression. There are two stages to developing data compression algorithms for various types of data. The first stage is commonly known as modeling. During this step, we attempt to extract information about any redundancy in the data and characterize it in the form of a model. The second stage is known as coding. A model description and a description of how data differs from the model are encoded, typically using a binary alphabet. The discrepancy between the data and the model is known as residual. For example, consider the following sequence number on the top, that we would require 5 bits for each sample to transmit or store the binary representation of these integers. However, by utilizing the data structure, we may express the sequence with fewer bits. When we plot this data, we observe that they appear to fall on a straight line, as illustrated in the bottom part. As a result, an equation on the top part can describe the data structure. Let's look at the difference between the data and the model to see how we can use it. The sequence provides the difference or residual. The residual sequence is made up of simply 3 numbers, -1, 0, and 1. If we assign a code of 00 to -1, 01 to 0, and 10 to 1, we must utilize 2 bits to represent each member of the residual sequence. As a result, we can accomplish compression by sending or storing the model parameters and residual sequence. Encoding can be exact if the compression is lossless or approximate if the compression is lossy. To summarize, as data continues to rise exponentially, compression will continue to play an important role in the data reduction. Data compression decreases the amount of space that data take up on the hard drive and the amount of time it takes to transfer or download them. These savings of space and time can lead to significant cost reduction. Organizations that store huge amounts of data, such as corporations and healthcare providers, can save money on the data storage since compression allows them to store more files with less capacity. Furthermore, because compressed files take less time to transfer over the internet, such firms are less likely to need to invest in costly bandwidth increases. And that sums up my presentation. I hope you learned something from the video. And remember that as Dwight Yoakam said, no compression or little as possible, that's how you get a good recording. Thank you very much for listening.